Let's take a look at this problem. Got f of x is equal to x to the third minus 3/2 x squared minus 6x plus 2. Now the first thing they're asking us to find is the domain. Well, it's a polynomial, so domain is negative infinity to positive infinity. Second thing they're asking us to find is the x-intercepts. To find the x-intercepts, you plug 0 into the other variable, so we'll plug 0 in for y. So we got 0 is equal to x to the third minus 3/2 x squared minus 6x plus 2. I'm going to use the intersect method. It's probably the easiest way for this. So I'm going to go to y equals clear x to the third, so x caret 3 minus 3/2 x squared minus 6x plus 2. And I'm going to do a second trace, choose intersect. Looks like -2, I don't know. Let's try -2 first. Enter on first curve, enter on second curve, and put -2 in for the guess. Now you have to have 0 on y2 for you to do that. So we get x is equal to -2. Next one looks like a little bit past 0, but let's do second trace, choose intersect, enter 0. And we get 0.3. Probably not a whole lot of need to take in more decimal places than that. And we got one more place. Our answer is where it crosses the x-axis. So do second trace, choose intersect, enter, let me put in 4 for the guess. You'll find whichever one's closest, which is 3.2. So those would be our x-intercepts. Is our domain. C. C is to find your y-intercept. So we plug 0 into the other variable. Well, f of x is y. So we'll plug 0 in for x. So we got 0 to the third minus 3/2 times 0 squared minus 6 times 0 plus 2. Well, 0 to the third drops away. 0 squared is 0 times 3/2 is 0. 6 times 0 is 0. So we're left with y is equal to 2. D. Our vertical asymptotes, there are none. You have to have a rational function to have any of those. E is our horizontal asymptote, and there is none. And F will be our slant asymptote, and it's none too. Again, you don't have any asymptotes unless it's a rational function. Okay, so G, increasing, decreasing. We need our first derivative. So f prime, x to the third becomes 3x squared minus 3/2 times x squared is 2x minus 6x becomes minus 6, and then 2 drops away, which gives us 3x squared. Those 2's cancel, so minus 3x minus 6. Now we want to set that equal to 0 and solve it. That'll give us our critical values. So we got 3x squared minus 3x minus 6 equal to 0. I factor a 3 out, and that gives us x squared minus x minus 2 equal to 0. That was GCF. Now we'll use PSD. X squared x, no number in front of our x squared. So this factors as 3 times x minus 2 times x plus 1. Zero factor property. It says if you get 0 on one side and you factor the other side, you set each factor equal to 0. Now we don't need to set 3 equal to 0 because there's no variable to solve for there. But we'll set the x minus 2 equal to 0 and the x plus 1 equal to 0. And we get x equals 2 and x is equal to -1. Well, we want to build a table of intervals. Over here is negative infinity. Over here is positive infinity. We want to choose test cases. We want to choose something between negative infinity and negative 1, like negative 2. Something between negative 1 and 2, like 0. And something greater than 2, like 3. And we want to plug them into our derivative. Now I could plug it in up here. This is our first derivative right here. You could also plug it into the factored form. So I could plug it in right here. And this might be a little easier. The 3 is positive, so I don't need to worry about it. I'll put negative 2 in for the x here. So we're going to have negative 2 minus 2 and negative 2 plus 1. Well, negative 2 is negative 4. Negative 2 plus 1 is negative. Negative times negative is positive, so this is increasing. If I put 0 in for x, I got 0 minus 2 and 0 plus 1. 0 minus 2 is negative. 0 plus 1 is positive. Negative times positive is negative, so this is decreasing. Now if I put 3 in, I got 3 minus 2, and I got 3 plus 1. 3 minus 2 is 1. 3 plus 1 is 4. Positive times positive is increasing. So, this is increasing from negative infinity to negative 1. Then it's decreasing from negative 1 to 2. And then it's increasing from 2 to positive infinity. Now, next item, min and max. If our increasing and decreasing change, that means we have a min or max. This one changes from increasing to decreasing, so this is going to be a max at x equals negative 1. And this is decreasing, changes to increasing, so this is going to be a min at x equals 2. So we're going to have a max at x is equal to negative 1, and we'll have a min at x is equal to 2. Now we want to plug those back into our original function, and I believe I have that original function. Yeah, maybe lying, but let me go look. If I press y equals, yeah, I have it on y1. So we want to make sure our calculator is set up for this, but we'll go to table setup, so we do second window. Down where it says independent, yours should say ask. If it doesn't say ask, down arrow to it, right arrow, press enter on ask, and you should see the highlighting change to it. And then exit out. Now we want to go to table. So I do second graph, and then we want to enter in these numbers, negative 1 and 2. So negative 1, enter, 2, enter. So this one, negative 1 is 5.5, and 2 is negative 8. So we're going to have a max at negative 1, 5.5, and we'll have a min at 2, negative 8. Okay, now we need to find our second derivative. This is to find I, concavity. Our first derivative is 3x squared minus 3x minus 6. So derivative of that would give us 6x minus 3. Well, we want to set that equal to 0 and solve it. So we got 6x minus 3 is equal to 0. Take the negative 3 to the right side, becomes a positive 3. Divide both sides by 6. And we get x is equal to 3, 6, or x is equal to 1/2. We'll build a table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. Something between negative infinity and 1/2, like 0. Something greater than 1/2, like 1. We want to plug them into our second derivative, which is right here, 6x minus 3. If I put 0 in there, 6 times 0 is 0, minus 3 is negative, which means this is concave down. If I put 1 in there, 6 times 1 is 6, minus 3 is positive, so this is concave up. So we have it's concave down from negative infinity to 1/2, and then it's concave up from 1/2 to positive infinity. Now, that was, what was that, I? J. You have a POI, point of inflection, if your concavity changes and a point exists there. Well, this changes from concave down to concave up, so we have a POI at x equals 1/2. So we've got a POI at x equals 1/2. Well, let's go back to our table feature, and we'll plug in 1/2. So I do 1 divided by 2, enter, and that gives us negative 1.25. So y is equal to negative 1.25. Now, if you want to change that to a fraction form, you don't have to, but if you want to, you exit out. If you put in negative 1.25, math, enter, we get negative 5/4. I'm not going to worry about it, though, because not all of them can you switch to fraction form. Some of them you have to leave in decimal. Not such a big deal for calculus, because we'd rather have decimal anyway. It means more if I tell you negative 1.25 versus negative 5/4. Well, let's graph it. Okay, our x-intercept's negative 2, 0.3. So negative 2, 0.3, and 3.2. And then our y-intercept would be 2. There's no asymptotes. Our min and our max. Where's that at? There it is. Our max is negative 1, 5.5. 3, 4, 5, 6. Negative 1, 5.5. Somewhere right there. So that's our max. Our min is 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2, negative 8 would be right there. Now our graph is originally increasing, so it's going up, hits this high point, then decreases from negative 1 to 2, hits this low point, and then it starts increasing. So let me try to sketch it as well as I can. So it's increasing, hits the high point, comes down, passes through there, reaches the low point, turns around, comes back up, and that would be the sketch of our graph. Now we've already graphed it in our calculator, and you see this is what our graph looks like. But again, we're kind of verifying the calculator. Calculator will give you the graph, the correct graph a lot of the times, but a lot of times they'll give you false pieces of the graph also. So this shows you how to get the true picture. And those are all our answers.